Hello everyone, myself Professor Sunil Kumar Thakur, Civil Engineering Department. In today's video lecture, we are going to discuss about subject that is Basic Civil Engineering and Mechanics, and subject code is that is BT204. In this video lecture, we are going to discuss about Unit 5th that is CG and MI, Center of Gravity and Moment of Inertia. Now, in this video lecture, we are going to discuss following topics that is centroid and center of gravity. Remaining topics we are going to include in next video lecture that is product of inertia, moment, inertia of area and mass, shear force and bending moment diagram. In this video lecture, we are going to discuss about only centroid and center of gravity. Now, what about centroid? Many students are confused about centroid and CG. When we talk about centroid, the plane figures that is like triangles, quadrilaterals, circles, rectangles, etc. have only area but no mass. The center of area of such figures is called centroid. Centroid. We have a given figures is the same as that of in many books. The definition of centroid and center of gravity are similar, but there is a little bit difference, that is centroid for only 2D diagrams and CG is only for 3D diagram. In centroid we are going to calculate area, and in case of CG we are going to calculate volume of a particular figures. Now, before calculating the numerical of centroid, first of all we have to know about different geometries, different formula required for figures. So we have formula required for calculation of centroid, that is rectangle. In this diagram we have a rectangle, and the length of the rectangle it is denoted by b, small b, and height of the rectangular means width of the rectangular it is denoted by small h. In case of rectangle, the centroid of such figure is exact on the center of the rectangle. This is the center, it is denoted by capital C, means centroid of a rectangle. It is half from this sides and half, that is b by 2, and it is also half from width, that is h by 2, and area of rectangle, that is a is equal to b into h. This is x distance, this is y distance from a particular positive x-axis or positive y-axis. Now, in second figure, we have a semicircle whose radius is small r. In case of semicircle, the centroid is little bit above of the diameter. This is the diameter of circle, somewhat above, that is C, it is capital C, that is centroid. In that semicircle, we have x distance, that is x, and when we talk about y distance, that is 4r upon 3 pi, and when we talk about distance from the top of the semicircle, that is r minus 4r upon 3 pi. And what about area of semicircle, that is pi r square by 2. Now, in third figure, that is right angle triangle. For right angle triangle, we have base of the triangle, that is small b, and height of the right angle triangle, that is h. And when we talk about centroid of right angle, for right angle, so we have x distance, that is b by 3. This is 2b by 3, and vertical height on y-axis, that is h by 3, and this distance is 2h by 3. Now, area of rectangle, we know that half into base into height, b into h. Now, for quarter circle, we have area, that is pi r square by 4. In quarter circle, the location of the centroid is C. We have x distance, that is 4r upon 3 pi, and y distance, that is 4r upon 3 pi from centroid. When we talk about this distance, this is total r, means r minus 4r upon 3 pi. Again, we have this x distance, that this is small r, radius of the same quarter circle, minus this x distance, that is 4r upon 3 pi. Now we are going to solve a given problem on centroid. So we have a given problem. Locate the centroid for the given shape with respect to reference x and y axis. So first of all, we have considered which quadrant the diagram comes under, which quadrant. So if there is no reference of quadrant, we have considered first quadrant always. Always we consider first quadrant. In first quadrant, both x value and y value we take positive. Now in this geometry we have a combination of rectangle, and we have a combination of semicircle and a combination of rectangle. So this numerical we are going to solve with the help of table method. So in this table we have a number of columns. First column of serial number. In second column we have shapes. In third column we have area of that shapes. Now in next column x distance, then y distance, then the value of ax, and in last column we have value of ay. So first of all we are going to discuss about this rectangular figure. In this rectangular we have a value, the width of the rectangle, length of the rectangle, that is 6 meter, and width of the rectangle, that is 2 meter. Now calculate the area of this rectangle, that is 6 into 2, 12 meter square. Now calculate x distance. This is our x distance, and we have a formula for x distance, that is b by 2. We have base 6 meter divided by 2, this is 3. Now what about y distance? This is our y distance. We have already formula, that is h by 2. We have height, that is 2 meter divided by 2, that is 1. Now multiply column this and this, we got value ax, and multiply column this and this, we got value of ay. For right angle triangle, we have a base, that is 3 meter, and height 2 meter. First of all, calculate the area of this right angle triangle. We have formula half base into height, that is 3. Now calculate x distance. So first of all we are going to calculate this x distance. Now add the value of b here, because we have to measure the x distance from centroid to positive y axis. This is our x distance from O to this centroid. So this is value base of rectangle, that is 6, plus value of this x distance, that is 3. Now calculate the value of y distance, that is y distance which is parallel to this y axis, that is h by 3. We have height, that is 2 meter divided by 3, we got a value, that is y distance 0.666. Now calculate the value of ax with the multiplying area into x distance, we got 21. Now calculate the value of ay, that is 3 multiply 0.666, that is 1.998. Now we have again semicircle whose radius is 3 meter. So first of all calculate the area of this semicircle. Calculate the area of this semicircle, that is 14.137. Now calculate the x distance of this semicircle. So this is our x distance, that is equal to r, means radius of that semicircle, that is 3. Now calculate this y distance. This is y distance up to here. Now add value of height of the rectangle in that y distance, we got a value of y, that is 3.273. Now calculate the value of ax, multiply this area into this x distance, we got 42.411. Now multiply this area into y distance, we got 46.27. Now add all the areas, summation of a, add 12, 3 plus 14.137, that is 29.137. Now add the value of summation of ax, we got this value, and summation of ay, we got this value. Rule for calculating x and y distance. First of all, locate the centroid. After that, draw perpendicular at that point to x and y axis from center. Now horizontal distance show x distance and vertical line show y distance. So each and every figure we have x distance and y distance already we mentioned in first slide, area as well as x and y distance of a particular geometry. Now we have a formula for calculating the centroid, that is x var is equal to summation of ax divided by summation of a. We have a value of summation of ax, put these values in this formula. From this table we got a value that is 3.411 meter. Again we have formula that is y var, that is summation of ay upon summation of a is equal to, putting these values from this table we got 2.068. So finally we have centroid, that is c is equal to x var and y var, that is 3.411 meter and 2.06 meter. This is x distance and this is y distance for this particular numerical. Okay, now in next slide we are going to discuss about center of gravity. Already I have told you that there is a little bit difference between centroid and CG. Methods are similar, but there is a formula calculations different. For CG, we are going to discuss about calculation of volume of given figures. Means we are going to discuss about 3D diagrams. And for in case of centroid, we are going to discuss about 2D diagrams. So in 2D diagrams, we are going to calculate area only. And for center of gravity, for 3D, for 3-dimensional figures, we are going to calculate volume of that figures. Examples of center of gravity, that is cylinder, prism, sphere, cone, cuboid, hemisphere. So we have some formulas for calculation of center of gravity. We have some object, that is cylinder, cone, sphere, hemisphere, cube and cuboid. Now one by one we are going to discuss about the geometry of these figures. First of all, we are going to calculate the volume of cylinder, that is pi r square h. We have x distance, that is capital R. We have y distance, that is h by 2. This is cylinder. And the CG of that cylinder is here. From here, we are going to calculate x distance and y distance. This is our x distance, that is equal to R. This is our y distance, that is equal to h by 2. Now, what about cone? This is a cone. We have a cone whose height is small h and whose base is diameter of circle. Now volume of cone, that is 1 by 3 pi r square h. This is x distance and the location of CG for cone is here somewhat above the circle, here g, small g. From here we have a x distance. This is x distance is equal to r, radius of the circle, x is equal to r, and we have a vertical height from center of the circle to this CG. This is y distance. This is equal to h by 4. H is equal to height of the cone divided by 4. Now what about sphere? We have a radius, that is capital R. When we talk about volume of sphere, we have 4 by 3 pi r cube. This is x and y both are similar in case of sphere, that is equal to r, small r, radius of the given sphere. Now for hemisphere, in case of hemisphere, the location of the centroid is here, somewhat above this circle here. Now what about volume of hemisphere? That is 2 by 3 pi r cube. 2 by 3 pi r cube. This is the volume of hemisphere. Now this is x distance r, which is equal to radius of the hemisphere. This is y distance from here to here, from x axis to this g, center of gravity. This is y distance is equal to 3r upon 8. Now for cube, we have a volume of cube, that is a cube. For cube we have x distance a by 2 and y distance a by 2, both are similar in case of cube. Now cuboid, for in case of cuboid we have a volume, that is length into width into height. When we talk about x distance, that is equal to b by 2, means base divided by 2, and for vertical height, that is h by 2, means height divided by 2. So these are the some examples of given figures, given geometry, whose volume as well as x and y distance we have. Now, next slides, we are going to calculate a numerical and calculate the value of CG for that particular diagram. So we have a numerical, that is a right circular cone of base diameter 100 mm and height 200 mm is placed on the hemisphere of the same diameter, that is 100 mm. Calculate the value of center of gravity. So we have a three geometry. First one is cone, second one is hemisphere. Sorry, we have two geometry, cone and hemisphere. So after the combination of this diagram, we have a new diagram, that is this diagram. So we are going to calculate the value of center of gravity for this figure. So this method is also calculated with the help of tabular method. Again, we have to draw tables. In this table, we have columns, that is serial number. In second column, solid figures. Now volumes, x distance, y distance, volume into x, volume into y. Now one by one we are going to calculate the value of these figures. First of all, we are going to discuss about cone. So we have a cone whose diameter is 100 mm and height 200 mm. First of all, calculate the volume of cone, that is 1/3 pi r cube h. Putting these values and calculate the value of volume. We have x distance, that is 50. We have y distance, that is 100. Now calculate the value of Vx. Multiply this column into this. We get the value of Vx. Now we get the value of Vy. Multiply this column into this column. We get Vy. For hemisphere, we have a area. With the help of the values given, we have a base diameter, that is 100 mm. Now radius is equal to 50 mm. Putting the value of radius here and calculate the volume of hemisphere, that is 2.61799.337. Now calculate the value of x, that is 50. Calculate the value of y, that is 31.25. Now calculate the value of Vx and Vy and putting these values here. Now we have a formula for center of gravity. X bar is equal to summation of Vx upon summation of V, and Y bar is equal to summation of Vy and summation of V. Putting these values from this table and calculate the value of X bar and Y bar. Finally we have X bar is equal to 50 mm and Y bar is equal to 77.083 mm. So this is our center of gravity. It is denoted by capital G is equal to X bar comma Y bar, that is 50 mm and 77.083 mm. Okay guys, thank you so much. Remaining topics we will discuss in next video lecture. Thank you so much.